Okay, so today we're talking about congruence and midpoint. We are going to apply the definition of congruence and midpoint. And then we're going to use that to find the length of segments. So I find it helpful to be able to compare things in tables. So I made this table for us. The symbol for congruence is going to be kind of like the equal sign, but it has a little tilde over the top of it. Okay, you already know the symbol for equality. It's just an equal sign. Okay, we use congruent to describe figures that have the same shape and size. Okay, let's bounce back over to equality. Equal is used to describe quantities. Okay, if you're like quantities, what the heck is that? When I say quantity, you can think of numbers. Right? Have you ever heard quality over quantity? It's like the amount. Okay, quantities that have the same value. So this is the recap part of the table. Congruence is for figures. Okay, equality is for quantities. Okay, don't say it like that. All right, so look at these little segments here. They have these little tick marks on them. These little ticks show that they are congruent segments. Okay, so PQ with the segment bar over it because we're talking about the figure. PQ and RS. Okay, these are figures. Are segments that have the same shape and size. Therefore, we say that PQ, the segment, is congruent to RS, the segment. So we can say segment PQ is congruent to segment RS. Okay, in a figure, these tick marks show congruence. Okay, so these tick marks are one of our examples of coding. Okay, we've already seen another type of coding, and that's for parallel lines. Remember when I had the parallel lines like this, and I would show that they were parallel by giving them the same amount of little arrows? Okay, that's the type of coding we've already seen. So when I ask you to code something, I'm asking you to make the ticks and the little arrows and stuff like that and label the picture with the information that you've been given. Cool? Okay. All right, congruent segments have the same length. Therefore, PQ is equal to RS. Okay, look at the difference between those two, between this one and this one. This is talking about the segments being congruent and having the same size and shape, the figures. This is talking about their measures being equivalent. Okay, so we can read this as the measure of PQ is equal to the measure of RI. Whoops, those actually are segments. Okay, so remember when we were looking at the parallel lines, and this pair of parallel lines had like one arrow, and then maybe you had another pair of parallel lines, and they had, let me make them not parallel to the other ones, duh. And these had two little arrows, okay? So not only do the little arrows tell you that they're parallel, but they also tell you what they're parallel to. These two are parallel to each other, but not to those two. Good? Okay. So the same thing with all of these little arcs and ticks. So if we're making a list of stuff that's congruent, we can say that segment AC is congruent to segment DF because it also has two ticks. Okay, would you please write the other two congruent statements for the other two sides? I think you can do it. Match them up. Like what's congruent to AB, segment AB? Okay, hopefully you said DE. Okay, and then of course, BC is congruent to EF. Okay, it's going to be the same thing for the little angles. If I have angle A congruent to angle, which one has two arcs? D has two arcs like angle A, angle D, I can mark them congruent. Okay, so these are just some examples. Now, do you see how everything on both of these triangles match? All the sides, all the angles. These triangles are actually congruent to each other. So I can even say that triangle ABC is congruent to triangle DEF. Okay, so those are just a couple of examples of congruence. And here's equality. Because AC is congruent to DF, we know that the measure of AC is equal to the measure of DF. They have the same length. Okay, and then we could do it for all of them. The measure of AB is equal to the measure of DE. Okay, the measure of angle A is going to be equal to the measure of angle D. The only one we can't do is we can't say that two triangles are equal. Because like, are we going to measure that in like inches, or are we going to measure it in degrees? Like, we don't have a way to measure degrees and inches at the same time. It doesn't exist. Questions? All right. Reminder about the segment addition postulate. Okay, a postulate or axiom is a statement that is accepted as true without proof. Okay, if and only if point B is between point A and point C, then we know that the measure of AB plus the measure of BC is equal to the measure of AC. So if it was me and I was in charge of naming postulates, I would call this the segment length addition postulate. But that just makes the name longer, so that's probably why they didn't do that.
Ms. W?
Yep.
You call it, when you said that, this is what I call it. This plus this equals this. It's really all it is, isn't it?
Right. Yeah. part
Yes.
plus the other part is the total, right?
Yes.
Okay. But you're going to have to know the name of it for your proofs.
Yes.
If you say this plus this equals this on your proof, I'm holding you responsible.
Okay, yeah, don't guys don't hurt that.
All right, now we get to talk about midpoint. Okay, if you just had to guess, what do you think a midpoint is?
Thumb in the middle.
It's the thing in the middle. Okay? Yes. So the midpoint M of a segment AB is the point that bisects. Okay, this is a word you need to know. Okay, what does the prefix bi mean? Two. Okay, sections is like chopping, right? So it's chopping in two. It's chopping in half. That's what bisects mean. It's dividing the segment into two congruent segments. I love words that just tell you what they mean in the way that they're spelled. Makes my life easier. All right, so we're going to draw a picture. So M is going to be the midpoint of segment AB. So here's AB and here's point M. Then we know that those two segments, AM and MB, are congruent and their measures are equal. So they get little ticks. That's called coding.
Maybe 1 tick or.
We can give them 3. They just have to match. That was a really good question. We usually start at 1, but. Okay, so point M is now going to be the midpoint of segment GH. And we know that GH is 10. The measure of GH is 10. So I want you to draw and code a picture. And then I want you to find the length of GM and the length of MH. Go. Start with a picture. You can literally copy the picture that I gave you above, just change the letters. Ask your neighbor if you need help. Okay, so if the whole thing is 10, what are each of the parts? Yeah. So then we say the measure of GM equals 5, and the measure of MH equals 5. Ta-da! Okay. Okay, the map is showing the route for a race. We are starting at point X, 600 feet from the first checkpoint C. Okay, well, I'm going to put that in my picture. So this length right here is 600. The second checkpoint, D, is located at the midpoint between C and the end of the race. Why? So D is not the midpoint for the whole thing, but it's the midpoint for this chunk right there. So what can we put on our picture to show that?
15,814.
Hold on, I'm just talking about like the little marks. Yeah, the little ticks. So we're just going to put ticks to show that these are the same. Okay. Now what were you telling me about the total race? I interrupted you. What were you telling me?
Oh,
X to Y, it's 15,000.
Okay. So this whole thing
Also,
is,
it's 6,000, not 600.
thank you. Okay, 15,840. Jeez Louise. So now we have to find the distance between checkpoint C and point D. So we're finding this right here because we don't know what it is. Any ideas?
Subtract 6,000 from 1580.
Yeah, we can do that. So we can take 15,840 and subtract the piece we know, and that will give us CY, the length of C segment CY. Okay, so
4912.
let me just make sure I get enough zeros this time. What did you say it was for?
4,920.
Okay.
Well, that's each segment.
Whoa, okay.
Hold on, wouldn't that be?
That's each segment.
Yeah, well,
Okay, yeah.
The one that you just
I
did,
will literally
9,000.
write down anything you guys tell me, so
That is
you gotta help me
9,000.
not look like an idiot, because I can do that all by myself. All right, so what is this?
9,840.
Okay, thank you. 9,840. And we're subtracting. Okay, so that is this piece is the 9,840. Now we don't want that whole piece. We want only half of it. We divide it by 2, and that's where they were getting that 4,000 number. They were just ahead of me. Okay, so now we're going to take this 9,840, divide it by 2, because D is the midpoint of that section of the race. Okay, and it was 4,920 millimeters? Feet. Okay, perfect. All right, guys, we made it. Good job. We're almost done. Oh, we're done with that problem. Okay, so let's just say that that equals, what is that, CD? Okay, now it's nice and mathy. It's labeled. It's got units. We're telling you what length it is. We're good. Okay. I know you want another proof. I know you're like, that was so much fun on Thursday. When are we going to do some more proofs? Today. Okay, so now we know that point D is the midpoint of segment EF. So let's mark with some ticks that these segments are congruent, that their measures are equal. So first we have to say what we've been given. So do we have an expression for ED?
Yes.
Yes. So they gave us the ED equals 4x plus 6. They also gave us DF. Thank you so much, math gods. 7x minus 9. First one's easy. You just write what they gave you.
And what do you call that? Given?
Yep, given. You know what I was thinking when I was like, write what they gave you? I was thinking it'd be funny if someone over here wrote a headache. Gave me a headache. No? Okay, guys, this is as good as it gets. You know, the jokes just get worse as the year goes on.
I thought it was kind of fun.
Thank you. It's kind of a dad joke.
It was kind of a day.
All right. So, what do we know about these two segments? They are congruent. Okay, because of the definition of a midpoint. Okay, so we are going to say that ED, the segment, is congruent to DF. because of the definition of midpoint. If it had said point D bisects the segment, we would say they're congruent because of the definition of bisect. Does that make sense? Okay. The next thing we know is that the two lengths are equal, right? If the figures are congruent, then the lengths are equal. We had that on the front. So we know that the length of ED is equal to the length of DF. And that comes from the definition of congruent. Okay. Now look up at your given. We have some expressions for ED and DF that we can substitute into this equation that we now have. So we are going to do that. So ED is 4x plus 6, and DF is 7x minus 9. Which property did we use? Substitution property, yes, yes. Okay, we're almost done. Now it just looks like your algebra ones that you've been solving since, week 1 of algebra, right? Now you know why your algebra teacher tortured you with all that stuff all year. Okay, where do you guys want to move the x's? To the right or to the left? Left? Okay, so we're going to subtract 7x from both sides to give us negative 3x plus 6 equals negative 9. We subtracted on both sides to keep the equation equal. So that was the subtraction property of equality.
Miss Debbie, can we say subtraction POE or do you want
We
to
can
spell it
say
out?
subtraction POE, but don't abbreviate subtraction because do you see how similar these two words are? If we start abbreviating them, they get really confused. Okay, so you're allowed to abbreviate property of equality and say POE. Everything else I need written out.
What's the point of writing that?
Torture, because you need to know what they're called. Sometimes if we're just memorizing the acronyms, we don't actually know what the thing is that we're naming. Okay, so, and torture. We just pass it on.
Love it.
Generation after generation. My teachers tortured me, now it is my turn. Do not rob me of my right. Okay, so I'm going to subtract 6 from both sides, and that's going to give me negative 3x equals negative 12. There we go, subtraction property of equality again.
Negative 9 minus negative 6 is 12.
No? Thank you.
Yes.
I was so excited to abbreviate POE, I forgot how to subtract. I don't know what I was thinking. All right, what's the last one?
Division.
Yeah. Okay, so when we divide both sides by negative 3, we become positive 5. Okay, now, if you're anything like me, when I was in high school, I was so excited to be done with this darn proof and have an X that I forget to plug it in and do the rest of the stuff it asks me. So Don't be like me. Look at this. What are we supposed to do at the end? We're supposed to find ED, DF, and EF. Jeez Louise. Okay, so that means we have to plug this x of 5 into each of these and then add them together to get the total. We can do it. So ED is 4 times the x plus 6. Okay, we know what x is. It's 5, so we're just going to plug it in, substitute it. 4 times 5 is 20. Add the 6, we get 26. Okay, I want you to do the next one. $35 minus 9. It's 26. I don't know why I was surprised that they're the same. It was supposed to be the midpoint, right? Okay. All right, add those together. What do we get? 52. You did it.